Yeah, I'm sorry about that. You've missed the first part of the lesson because the video camera wasn't working. So I'm sorry, you've missed the explanation of why these work. I just gave a short explanation, and you've kind of missed it too. And I'm sorry. That's okay. Crystal will teach you why they work. Crystal, can you remember the reason why that works? Can anyone explain? Can anyone explain really quickly? If someone asked you why this is true, what would you say quickly? Yeah, well, yeah. This is almost like a common ratio, isn't it? Yeah. U to the n plus 1 divided by u to the n is simply like r, isn't it? It's a common ratio. So what we're saying here is, if the common ratio at infinity is less than 1, then the series is going to, yeah, it'll converge. Because it's like very, very similar in a way to looking at what happens with a geometric series. Yeah? In a geometric series, if the common ratio is less than 1, we have a sum to infinity. Yes, we actually have a convergent value. And that's what's happening. So if infinity, we get this sort of thing happening, then we find the infinity terms are converging. Yeah? And the terms before infinity, which are known, are also converging. So the entire series will converge. Of course, this is also true. If the common ratio at infinity is greater than 1, it will diverge. And when the common ratio equals to 1, we're unsure, and we'll look at that in our next class. That is our next class. What actually happens when it equals to 1? How do you investigate that further? And we'll do that in the next class. But let's quickly just run through this and let's go and have a nice weekend. Okay, we'll finish chapter 3 on Monday. And let's see if we can get all of chapter 4 done next week. We'll try. Wouldn't that be exciting if we could? Anyway, let's just get to this. What have we got here? We've got 10 to the power of k, 10 to the power of k plus 1. So certainly on the denominator, I think you can see that we're going to end up with 10 to the power of just 10, aren't we? And then this will be k to the power of 10, yeah, on, sorry, k plus 1 to the power of 10 like that. Now what do I do, ladies and gentlemen? Well, that's easy as well. We can bring that outside as well, can't we? And then let's just get rid of the absolute sign. This is all going to be absolute. Yeah? And let's look at what happens with that ratio. Are you ready? So my next step would be this. Mathematically, k to infinity. This will become 3 on 10. And then what I'm going to do is, because they're raised to the both raised to the power of 10, I can actually put that into a in like this. I can go k plus 1 on k all to the power of 10. Believe me? That by that is the same as that. Let's take the limit as k approaches infinity. Can I do that? I should divide that by k, divide that by k, and divide that by k as well. Yeah? So let me just put a little arrow up here. So I've got that equals to 3 on 10 times by the limit as k approaches infinity of 1 plus 1 divided by k on 1 to the power of 10. Of course, that's, if we take the limit, that's going to equal to 0, isn't it? So 1 on 1 to the power of 10 is 1. We end up with simply 3 on 10. So let's take the limit. So we get 3 on 10 multiplied by 1 plus 0 on 1 to the power of 10, which equals to 3 on 10. Vincent, will my series converge or diverge? Why? That's less than 1. So at infinity, what's my common ratio? At infinity, what's my common ratio? 0.3, isn't it? Yeah? So just before infinity, sorry, go. How can I go from there to there? From here to here? Well, okay. Well, minus 3 to the k plus 1 divided by minus 3 to k. Do you understand that? That will, the k's, and I'll just be left with minus 3 to the power of 1, which absolute value becomes 3. Okay, how about this one? 10 to the power of k, 10 to the power of k plus 1. Do you get that will be 10?
Oh.
Yeah? divide those out, okay? You with me now? Good, let's do another one, shall we? Let's look at the next one. How would I know to use the ratio test on the next one? Because why? It's got factorials and it's got powers in it, yeah? So let's look at how we do that one, shall we? Blue texter.
Can you write an example conclusion?
Well, we probably should, yeah. We should, well, I should say this here. Diverges. Why does it diverge?
Converge.
Oh, sorry, converges. Thank you. I always keep doing that, don't I? Converges why?
Using the ratio.
Yeah, that's right. Converges via the ratio test. Let's do another one. B. So again, same thing. This is our last test, everyone. Okay, let's do that one, shall we? Converge or diverge? What do you think? I've got a feeling this is going to diverge. It's hard to know though, because you've got this here as well, alternating series that can cause things, but we have to find absolute convergence, don't we? So I've got a feeling this is going to k factorial. Which one do you think will grow faster? K factorial or k to the power of k? Yeah. Okay, agreed. In other words, 1,000 to the power of 1,000 will be a bigger number than 1,000 factorial. It should be. Yes, I agree. It will be, won't it? Because it'll be 1,000 times 1,000 times 1,000 times 1,000, where factorial will be 1,000 times 999. Yeah, so it's getting smaller. Great. Good. So we're expecting kind of this to diverge anyway. So let's just see if we can now prove this via the... How do I know to use the ratio test? Well, generally speaking, if it's got factorials in it, ratio test is the test that you need to apply. Yeah? So let's do this. So we've got the limit as k approaches to infinity of the absolute value. Now, if I take the absolute value of -1 of my sine generator, of course that's just going to be, well, I've got to go minus k plus 1, which would be -1 k plus 2. Do I even need to worry about that? Really? Is it silly, me even putting that in? If I take the absolute value of that, it's just going to be 1 each time, so let's not even worry about that. We've got k plus 1 factorial divided by k plus 1 to the power of k plus 1 times by the reciprocal of, so this will be k to the power of k divided by k factorial. Don't even need the absolute sign anymore, it's all positive. So let's go down to the next step. Yeah, is this making sense, Vincent? Sorry, Nathan? What's this term here? What's that? That is u to the k plus 1. Yeah? What's this term here? This is 1 divided by uk.
So do you just ignore the sign?
Oh, yes, I have y.
Because
It's the absolute value. Yeah. However, probably shouldn't really. I mean, it makes sense to do this, but yeah, you take the absolute value, so the sign generator goes. Because we're doing absolute convergence. If it converges absolutely, it converges. Right, I think you can see, what's k plus 1 factorial on k factorial? K plus 1, do I need to do that? Maybe I should for those who have forgotten how to do that. That's going to be k plus 1 times by k factorial divided by k factorial. Yeah? So that's that there, that there. Then I've got multiplied by k to the power of k. What I'm going to do here though is I'm going to write this like this. I'm going to write this as k plus 1, and then write this as k plus 1 to the power of k. Did you like that? Is that alright? See that? Yeah? So I've just gone k plus 1 by itself, so to the power of 1, because it's the same base, I can split that up. Now that's really cool to split up like that, because what I can do now is do some cancel. That will cancel out with that. That will cancel out with that. Yeah, and what I'm left with is this, the limit as k approaches infinity of k on k plus 1 to the power of k. Now what can I do? If I remember right, this is a really quite a nice one to do. I'll show you. This is a bit of a trick here. Are you ready? What I'm going to do is I'm going to reciprocate that like this. I'm going to write it like this. You guys are going to go, why are you doing this for? Watch this. Okay, we're ready? I'm going to go 1 divided by k plus 1 on k to the power of k. Can I do that? All I've done is I've gone 1 divided by that and flipped it up. So I've really gone like this. 2 to the power of k is equal to 1 divided by 1 divided by 2 to the power of k. Yeah? So I've just taken this and I've gone 1 divided by, but then I've reciprocated that. Agreed? Why have I done that for? Well, you'll see. Let's go to the next step. I'll just steal this bit of board here. Let's just go to the next step. That's equal to the limit. See who gets this. Don't look at your book. Otherwise the answer will be given away, and it's a really nice answer. This is 1 divided by 1 plus 1 on k, all to the power of k. Does anyone know what that equals to? What's this limit as we take the limit as k approaches infinity? Who said that? It's e. Do you remember this limit? Do you remember the limit as n approaches to infinity of 1 plus 1 divided by n to the power of n is equal to e? And infinitely small increases done an infinite amount of times produces the multiplier e. So this becomes, if we take the limit, it becomes 1 on e. Is 1 on e less than 1? Certainly is, therefore we have a convergent series. One more. Maybe we'll get a divergent one, I'm not sure. I think this one is divergent, so let's check it. Yeah, I won't rub that up. I'll rub this out here. Oh, you need that too, do you? It'll be on YouTube anyway. Brian put this on YouTube for me. Thank you, Brian.
干嘛？我书上看到也想起来了。
Let's do the last one. I'm writing it out in blue, so let's do this last one here. And then we can maybe do one out of the book or something. Oh, you've got an assignment to do this weekend, haven't you? What about that one? Susan, converge or diverge? First guess. What's happening at infinity? As those numbers get really, really big, really big, which one's going to win? The top, yeah? This one here? Let's see. Let's see. So you think converge then? Possibly. Possibly. Converge? Well, let's just see. Yeah? So how do we do this? Let's go. Let's apply the ratio test. How do I know to apply the ratio test? It's got factorials or exponentials in there. Generally speaking, not a bad way. Why? Because you can't integrate factorials, can you? So we can't use the integral test. Yeah? And comparison tests just aren't going to work here. So we've got to do this. So here we go. The limit, last one, as k approaches to infinity of, here we go. Now, I don't have to worry about absolute. Everything is already positive. But yes, I should apply the absolute. But I've got here 2 to the power of k plus 1. Put that in a bracket, factorial. Yeah. Divided by k plus 1. Put that in a bracket, factorial squared. Multiplied by k factorial squared divided by 2k factorial. Right, next step, probably just write that out again, would we? Or unless I can write k plus 1 factorial. Let's just expand this out. This is 2k plus 2 factorial, isn't it? Yep, so I might write that down. So I'll expand this. This becomes 2k plus 2 factorial. What I could write here on this one, what should I write here? I might write that as, that's k plus 1 factorial squared. So that's like twice after it, isn't it? So that will actually be k plus 1 all squared. Yeah, and then that will be k factorial all squared. Yeah? So k plus 1 times k factorial is k plus 1 factorial, and then if I do it again, k plus 1 times k factorial, so that works out. So that will be times by k factorial squared on 2k factorial. Now that's going to cancel out with that, yay, so that's good. Next line. This one's a bit tricky. Remember, this will be 2k plus 2 times by 2k plus 1 times by 2k factorial. Won't it? Good. So this will be 2k plus 2, 2k plus 1 times by 2k factorial, and that will cancel out with that one. Divided by k plus 1 all squared. Times by 2k factorial. That will cancel out with that. Yeah? And I could take 2 out as a common factor here and cancel out one of the k plus 1s. Would you do that? I would. So I don't think they do that in the textbook, but that's what I'd do. I'd go limit as, in fact I'll take the, I'll take out the 2. So this will become 2 times by, that's not very nice, 2 times by the limit as k approaches infinity of k plus 1 and 2k plus 1 divided by k plus 1, k plus 1. K plus 1s will cancel out. Yeah? And let's divide by k, shall we? Yep, so we'll divide by k. So we end up with 2 times the limit as k approaches infinity of 2 plus 1 on k divided by 1 plus 1 on k. That'll be 0, that will be 0, so 2 on 1 will just become 2 times by 2 is 4. 4 is greater than 1, therefore it's divergent. And there's my 3 examples out of the textbook. Nice ones, aren't they? Okay, let's just practice one more where I don't do it. Yeah? Fair? Can I rub out A? And I'll write 1 out of the book so that you can have 1 practice by yourself, and then we'll call that a day. Yeah? Because you've got homework to do. I'm sorry, it would have been nice to get the next chapter done, but let's not hurry. Maybe after this question we could just quickly run through all of our tests just in our head as well. Let's do that. So the question I want to do is from page 86, everyone. Let's look at 86. I'm going to choose what looks like to be one of the hard ones. Let's choose B1. Looks a bit tricky, doesn't it? I'm not sure what the answer is straight away by looking at it. We've got k factorial divided by k squared times e to the power of k. And that's from 1 to infinity. And there's no sign generator, so see if you can do that one yourself. Converge or diverge? I have no idea just by looking at it, but see what you guys and girls can do. Got a pen and a piece of paper? Need a piece of paper? No?
Oh no.
哦，是成了。那大爷，
我也可能觉得好累。
这么擦钱呢？
我看看上网币。我上课都免费。
然后往下怎么解？我解不开了。
对啊，我这。
对啊，我刚才没有解开，我操。对，那我可以加在上面。
上一个月的上网课。我长得就很像简浩啊。我长得太像简浩了。是，哎呀，我不想看。有，你是那个。
这个一方，对啊，你放进去写的，接下来一方放进去。
我把它开了。
我把它开了。我顶不住，你还是开了。我肯定要开，不能开的。
不能开。
不能开一个。
为啥不能开？
你开了，它后面还存着东西的。
这个一般也都是可以放到外面去的，因为它是空的。你可以分开开的呀。
哦，你封掉了。
把前面的给开了，一样的呀。
不行。
我是为了把这 K 方给弄掉。
对啊，K 方你用不掉的呀。
可以啊，
不能用掉。
怎么用来着？忘记了。
你开下去，其他可以得是可以
上下都是不用的呀。不是啊，我的意思是把它变成这个 K 方加2K 加1。
对啊，2K 分加1。
That's going to just be infinity, isn't it? Yeah. So I'm just trying to find a way. If I divide by k,
应该也是一样的呀。
那么它，那不就是它乘1/1吗？应该直接觉得是它1/1。
therefore diverge. So in this case, it's interesting, isn't it? K factorial growing much faster than that times by that, isn't it? Yeah? What's that? Because I'm going to end up with a 0 on the bottom, aren't I? I'll end up with 1 on k. 1 on k squared, which would be 0 plus 0. I don't want to end up with a 0 on the bottom. I don't want a 0, no.
So but if that happens, you can always use the L'Hopital.
Yes, yes. Oh, I could use L'Hopital's rule then.
But we have to divide it by k. We have to divide it by k every time we calculate.
Yeah, we'll use L'Hopital's rule. Yeah, very good.
Just by k, not k squared.
I wouldn't divide by k squared because I was worried I was going to end up with 1 on k plus 1 on k squared. If we take the limit, it'll be 0 and 0. So it'll be something on 0. I just didn't want that. I didn't want to have 0 on that. Did that make sense? That's all. I was just worried about.
1可以贴到前面去的。对啊，你不早点说，这个
I didn't want to divide by 0. That's all. I'm not sure, but.
If we divide by k squared, we become a constant. 0 is less than 0.
Yeah, I know, but when you take that, it's undefined because you're dividing by 0. And do you know what I mean? Like when you take the limit, it's undefined rather than equal. I know this one here. I know that's infinity. When it's undefined, I don't know what it is. That's all. It probably is infinity, but yeah. Well, it is, but this is a better logical way why it is infinity. Or use L'Hopital's rule. Very good. Agreed, everyone? Okay. I think that's enough for this week. Thank you for coming. Sorry it's a very short class. I would have liked to have done a little bit more, but let's move on to Power Series. We'll finish on Monday. We'll finish Chapter 3 Monday. Can I get that assignment Monday? Are you really busy this weekend, are you?
Yes.
Yes.
Why?
POP. No. IOC.
Which day then can I get it?
Wednesday.
Anytime next week.
Okay, sometime next week, yeah.
Okay. Thank you.
That's fair. I know you're busy. Cheers. See you on.